An atom is the smallest indivisible unit of matter. Atoms are very small, about 100 picometers in diameter. Its structure consists of three subatomic particles, the proton and neutron, which forms the nucleus and are collectively known as nucleons, and electrons orbiting the nucleus. Furthermore, electrons orbiting the nucleus mean that the atom is mostly empty. The proton is an electrically positive particle and is the only of the three subatomic particles that is constant as it defines the identity of the atom. Remove three protons from a lead atom and it becomes a gold atom. Modern day alchemy. The neutron, on the other hand, is an electrically neutral particle and has the same mass as the proton. Atoms of the same element need not have the same number of neutrons. These atoms with the same number of protons but different number of neutrons are called isotopes. Isotopes may have unique names, but most of them are named after their respective elements and number of nucleons. While isotopes generally differ by mass, isotopes with a larger number of nucleons being heavier, certain isotopes possess radioactive properties. Electrons are small, about 1/1800th the mass of a nucleon, electrically negative particles. As atoms have an overall neutral charge, the number of electrons is equal to the number of protons so that their opposite charges cancel out. Electrons orbit the nucleus in shells, occupying the lower energy shells before occupying the higher energy shells when the lower energy ones are full. This makes the inner electron shells fully occupied with a stable configuration. The outermost electron shell is filled with electrons known as valence electrons and is not fully occupied and does not have a stable configuration. The only exceptions are noble gases, which have the outermost electron shell fully occupied with a stable configuration. As such, atoms lose or gain electrons whichever is easier, to form a stable electron shell configuration known as a noble gas configuration. These atoms become ions and, lacking a balanced count of protons and electrons, have a net electric charge. Ions formed from losing electrons have a net positive charge and are called cations, while ions formed from gaining electrons have a net negative charge and are called anions. Electrons are also responsible for the bonding between atoms by playing matchmaker when these atoms form a stable noble gas configurations. Atoms can bond by giving electrons to other atoms, forming ionic bonds, or by sharing electrons amongst themselves, forming covalent bonds. These match-made bonded atoms are called molecules. Information on individual atoms can be found in the periodic table, where the elements are arranged and grouped by their chemical and atomic properties. Each element contains three main pieces of information on its atom: the atomic number, also the number of protons in the atom, the element's name and its chemical symbol, the atomic mass in atomic mass units, AMU, where 1 AMU is 1/12 the mass of a carbon-12 atom. As a carbon-12 atom has 6 protons and 6 neutrons, or 12 nucleons, 1 AMU is equal to the mass of 1 nucleon, plus half an electron. But considering that electrons have a very small mass, the half electron mass can be pretty much ignored. But why then do most elements have atomic masses with decimal places instead of the expected natural numbers, considering that there are no partial nucleons? This is because the atomic mass does not take into account single atoms, but all isotopes of the elements and their respective frequencies, averaged. Atoms and molecules may be small and light, but a sufficient number of them would give them significant mass. How many exactly? 6.022 times 10 to the 23rd power, also known as Avogadro's constant. This number of atoms or molecules would form a mole. 1 mole of an atom or molecule is equal to its atomic or molecular mass, in grams.